Welcome SYBsc Physics students. I am VP Devre, Department of Physics, New Arts Commerce Science College, Shevgaon, District Ahmednagar. SYBsc Physics Semester 4. Paper 1st, Oscillations, Waves and Sound. Chapter 1, Undamped Free Oscillation. Undamped free oscillation, and today's topic is a composition of the two S.H.M.s, and here we study the composition between the two perpendicular linear S.H.M.s or the frequency ratios, that is a 1/1. So for that purpose here, composition of two S.H.M. So when a single particle is subjected to two or more linear S.H.M.s, then the resultant displacement of it depends on the frequency, phase angles and the amplitudes of the components S.H.M.s. Okay, so here this resultant displacement, it depends upon resultant displacement is depend on frequencies phase angles and amplitudes. Frequencies, phase angles and the amplitudes. Okay, so here this phenomena, this phenomena which is known as the composition of two linear S.H.M.s. Composition of two linear S.H.M. Composition of the two linear S.H.M. That is, when a single particle is subjected to two or more linear S.H.M.s, then the resultant displacement of it depends on frequencies, phase angles and amplitudes, and this phenomena is known as the composition of the two linear S.H.M.s. Okay, and now here we shall now discuss the methods of finding the resultant of such simultaneous motions, and that is the first is the composition of two mutually perpendicular linear S.H.M. For frequencies ratio 1:1. For frequencies ratio 1:1, that is analytical method. Okay, so there is the composition of the two mutually perpendicular linear SHMs for frequency ratio 1:1 analytical method. So for that purpose here, so let the two S.H.M.s be described by the equations. So what is that two S.H.M.s? X is equal to A sine omega t plus theta. Omega t plus theta. Then y is equal to b sine omega t. Suppose this is called equation 1, this is equation number 2. Equation 1 and the equation number 2. And both the SHMs have the same period 2 pi upon omega and the same frequency omega upon twice n. So therefore the first SHMs is along x-axis and is ahead of second SHMs, which is along y-axis by angle theta, and thus theta is a phase difference between two SHMs. Okay, and so their amplitudes are different. So their amplitudes are different means what? A and B are the amplitudes. Okay, so here these are from equation 1. From equation 1. X upon A is equal to sine here omega t cos theta plus cos omega t sin theta. So here sin omega t plus theta is written as trigonometric sin omega t cos theta plus cos omega t sin of theta. This is the equation number 3. Equation number 3. And here from equation 2, sin omega t is equal to y upon the b, and here sin omega t is equal to y upon the b, and so therefore here sin omega t is equal to y upon b, and there is a cos omega t is equal to under root of 1 minus y square upon the b square. So substituting in equation 7 here, substituting in equation 3. Substituting in equation 3. So here we write so by substituting here we write x upon a is equal to y upon b cos of theta plus square root of 1 minus y square upon b square sin of theta, sin of the theta. So therefore here x upon a minus y upon b cos of theta is equal to square root of 1 minus y square upon b square sine of the theta. Okay, and here squaring and for this squaring we write x square upon a square minus 2xy upon ab cos of theta plus y square upon b square cos square theta, and that is equal to here 1 minus y square upon b square sine square theta, and that is, it is written as x square upon a square minus 2xy upon ab cos of theta plus y square upon b square, here these are cos square theta plus sine square theta, and that is equal to sine square theta. So it is these are, when we multiply this sine square theta, so here this coming here, and so this is the remaining sine square theta, and so therefore here the next step, x square upon a square minus 2xy upon ab cos of theta plus y square upon b square, and that is equal to sine square theta. So here this equation is equation number 4. X square upon a square minus 2xy upon ab cos of theta plus y square upon b square is equal to sine square theta, that is equation number 4. So here these equation represents the resultant motion. This equation represent as the resultant motion, and it is a general solution of an ellipse whose axes are inclined to the coordinate axis, and hence the path followed by the particle is in general an ellipse, and the resultant motion is determined by the value of the phase difference, that is the theta. Okay, so here this equation, so here it is the resultant motion, equation of the resultant motion, and it is a general equation of an ellipse. General equation of an ellipse. Okay, general equation of an ellipse. So there are the few special cases of the phase difference, and theta, these are theta is where theta is the phase difference. Okay, so here there are the few cases of these phase difference. So in this case, when we consider the case first, if the SHM are in phase theta equal to 0, if the SHM are in a phase difference, that is a phase, that is theta is equal to 0. So therefore equation 4 becomes, what is it, equation 4? So therefore here x square upon a square minus 2xy upon ab, then cos of theta plus y square upon b square, that is equal to the 0. You see here cos of here is 0 and that is equal to the 0, that is 1. So therefore here x upon a minus y upon b here bracket square, and that is equal to 0. Cos 0 is equal to 1 and here this is the 0. So x upon a minus y upon b square, that is equal to 0, and so therefore here we obtain x upon a is equal to y upon b, and so therefore we write y is equal to b upon a into the x. Y is equal to b upon a into the x. This is a case. So this equation y is equal to b upon a into x, this is equation number, that is a 5. So this equation represent as a straight line through and the origin. Straight line through the origin and having the slope, that is the b upon a, and the resultant motion is a SHM along the straight line, and if further the amplitudes are equal, that is a is equal to b is equal to a, then the straight line makes an angle of the 45 degree with the x axis, of the 45 degree with the x axis, and therefore here when we take this vertical diagram, this resultant motion here, so for that purpose so this is the y-axis, this is x-axis, and here 0, this is b, this is a, and here a, b, and here this angle is the 45 degree. A is equal to b, and again here a is not is equal to b. Okay, so it is not the 45 degree. Okay, and this figure is shows as the resultant motion. Okay, and here this is the case 1, then the case second. If theta is equal to pi by 4 and cos theta is equal to, therefore we say that the 1 upon root 2. Cos theta is equal to 1 upon root 2. So therefore this equation 4 reduces to this equation 4, which is reduces to x square upon a square minus 2xy upon ab 1 upon root 2 plus y square upon b square is equal to 1/2. So this equation is this equation is equation 6. This equation is a 6. So this equation represents an oblique ellipse. This is the oblique ellipse to the inclined to the x-axis, and if further a is equal to b, it is an oblique ellipse whose axis is inclined to the axis of an angle 45 degree as shown in this particular figure. And here when we draw the such figure here, so here this is the 45 degree, this is y-axis, this is the x-axis, this is 0, and here this is this figure which is shows the elliptical path. Okay, so this is the case second. Then the case third, if the phase difference is equal to pi by 2, if theta is equal to pi by 2, so therefore cos of pi by 2 is equal to 0. Cos of pi by 2 is equal to the 0. And then cos of pi by 2 is equal to 0. So therefore this equation 4 reduces to x square upon a square plus y square upon b square, and that is equal to 1. So this is the equation number 7, and here this equation represents a symmetrical ellipse. And here these whose semi-major axis of length a coincide with the x-axis, and the semi-minor axis of the length b coincide with the y-axis, and thus the resultant motion is not SHM but an elliptical motion is which is shown in this particular figure. And here this equation becomes x square plus y square is equal to a square, which is the equation of the circle when the a is equal to b is equal to a. Okay, and we write the x square plus y square is equal to a square. Okay, and here which is equation of the circle, so here the resultant motion is the circular. And so therefore here we write elliptical and the circular path. So when we draw such diagram, is the x and the y, and again y, and this is the x, a and the a, this is 0. So this figure which is represent as the elliptical and circular path. Okay, so this figure represents as the elliptical and the circular path here. So this is the case third, and now the case fourth. So in case fourth, if theta is equal to 3 pi by 4, So therefore cos of 3 pi by 4 is equal to minus 1 upon root 2, and sine of 3 pi by 4 is equal to 1 upon square root of 2. And so the equation of 4, which is becomes as x square upon a square minus root 2 upon ab into xy plus y square upon b square, that is equal to 1/2. That is equal to the 1/2. So here this is the equation number 8. Equation number 8. So here this equation again represents and the oblique ellipse. However, in this case, if the amplitudes of the SHMs are equal, the ellipse is inclined to the x-axis at an angle 3n by 4. So here when we draw this diagram, so such type of diagram, that is y, this is x. So here 35 degree, 135 degree, this is the 0, so here this figure represents the elliptical part. This figure represents the elliptical part. So this is the case 4, and the last is the case 5. If theta is equal to if theta is equal to pi, and so therefore cos pi is equal to -1 and the sin pi is equal to 0. So therefore the equation 4 becomes this x square upon a square plus 2xy upon ab plus y square upon b square, and that is equal to 0. So therefore x upon a plus y upon b, and that is bracket square, and that is equal to 0. So therefore y is equal to minus b upon a into the x. Y is equal to minus b upon a into the x, and this is the equation 9. So this equation represents the straight line passing through the origin and having a slope b upon the a, and so the resultant motion is a SHM along this straight line, and further if a is equal to b is equal to 0, then the straight line make an angle of the 3 pi by 4 or 135 degree with the x-axis, and which is shown in the particular figure here. So therefore when we draw such figure here, this is y-axis a, and so here a is not equal to the b. This is the x-axis, and here these are 135 degree A is equal to B. So here this figure, which is shown as the straight line path. Straight line path. So here these figure shows the fifth case of these for the composition of the two linear SHMs, and the above consideration makes it clear that so long as the frequencies of the two SHMs are perpendicular to each other, that is the 1:1 ratio, perpendicular to each other, are equal. The resultant motion depends upon their relative amplitudes and the phase difference, and if the amplitude are also equal, then the phase difference along determines the nature of the resultant difference. Okay, so this is the composition of the two linear SHMs, perpendicular SHMs, for the frequency ratio, that is the 1:1 methods. Okay, so thank you all of you, and in the next video lecture we will see the composition of the two linear SHMs, perpendicular SHMs, for frequency ratio 2:1 analytical method. Okay, so thank you all of you.